So welcome to the Friday of Aerospace UP Week. We've had a whole week of exciting events at this time each day for the last 5 days. We're covering different aspects of the aerospace industry, and today is the day we're talking about innovation in the more traditional sense of technology innovation, but also looking at how we can think about innovation in different ways. Next. Just to remind you that as of next week, we're going back to our regular coronavirus schedule with our drama additive hour on the Tuesday, and we're going to spend 3 weeks in a row looking at other industries and how they are adopting additive and implicitly comparing and contrasting with the aerospace industry, which we're working mostly on drama on. Oh, well done, Pamela. So yes, we're back to 11:30. So thanks for reminding me there. That's good. We moved to 11 o'clock for the drama, for the additive, for the Aerospace Up Week, so that we could finish at lunchtime again, 12:30. But yes, we're back to 11:30. So if you do join us, perhaps we'll leave a message up. We need one of those cups of tea that's steaming, Pamela. We just leave that up at 11 o'clock for anybody that gets the timing wrong. And then we're moving on to the Aerospace Up Hour, as we've done in the past. We've got our 10th one next week, where we'll be looking more generally at what's happening in the industry and reporting to each other on matters that are happening in our companies and in our supply chains. So, and that will continue through till approximately when Farnborough was going to be, so 3 weeks continuous. And then over the summer, we're going to move to a couple of times a month. So 3 times over the summer, just to give everybody a break when things slow down. And then we'll be starting up again, we think, in September. We don't see any reason at the moment for us not to continue with these hours for the rest of the calendar year. Next. So there's the agenda for today that you've seen from the joining instructions or the invitation that was sent out that's drawn you to join us today. We're going to look at the MAA survey, and then we have some special guests who are all inside our own Aerospace Up team today, which is absolutely brilliant. So you'll be hearing from the people that you'll be working with if you become part of the Aerospace Up program, which we hope as many of you as possible will do. Next. So over to you, Pamela.
So a few practicalities. If anyone hasn't found it yet, please put on your chat box. Looks like a little text message on the menu bar that you have in front of the display slide or the pictures. In there, put your full name and affiliation if you could, because it's a mixture of what we see, whether we see what people are really called or their email address or ID. So put that in there now, helps us to know who's here when we get to having a bit of discussion later. Do keep displaying the chat during the webinar and flag up any questions you'd like to ask to us presenters there. Flag them up with a brief topic if you like, rather than spending a long time typing it, because we've noticed that if you spend a long time crafting your question completely, then maybe the moment can pass. But we will be generally leaving questions till the end of each presenting slot, and we'll bring you in to unmute yourself and ask your question at that point. You can use the raise hand function, especially useful if we get into a bit of discussion towards the end of the hour, the session. And in fact, we do tend to leave the meeting open for a good 15 minutes after the 12:30 close, just for some more informal questions and networking, just like we would if we were meeting face to face. We are recording this this session, and it will be made available pretty much in its entirety. We'll edit out anything too egregious. Usually it's my errors with the presentations or something like that, but also the chat will not be visible in what's broadcast, just what's the visuals and what's spoken. So don't worry about being quite open in your discussions in the chat box. That won't go beyond the attendees here today. So if those of us who aren't presenting immediately could switch off cameras, I will also mute all just now, and those who are speaking will unmute themselves at the correct moment.
Great, thanks, Pamela. So just to remind everybody, as Pamela did, about the Aerospace UP Week, so if you weren't able to attend one of these meetings, we've filmed them all. We'll do some light editing, we think, and make them all available next week. That'll take us a little while to do, but you'll be able to point your colleagues towards these. We didn't know that we would do this, but some of the material that we've generated from our member companies and experts in general has been very valuable. We want to share that with everybody as soon as we can. So let me hand over to Christine, who's going to talk a little bit about the Aerospace UP programme and come back to talk in more detail about the grant aspects of that later on.
Thank you, Andrew. So yeah, hello everyone. Welcome to the final session today of the Aerospace UP Week. My name is Christine Koch and I'm the Business Development Manager at the Institute for Aerospace Technology at the University of Nottingham. And yeah, I'm part of the delivery team of the Aerospace Unlocking Potential program. So Aerospace Unlocking Potential, as hopefully a lot of you already know, if you've been with us for this week and before at our other Aerospace UP hourly events. Yeah, so Aerospace UP is a program valued at £20 million, which aims to support the aerospace supply chain in the Midlands by helping to unlock its innovation potential. And yeah, as you can see from our branding, the project is being delivered by the University of Nottingham and the Midlands Aerospace Alliance. It's also supported by the European Regional Development Fund, which helps businesses to access funding and expertise to improve their performance through innovation in all aspects of their enterprise. And yeah, this funding is secured. The funds are already in Britain. They're guaranteed by the government. So whatever is going to happen around Brexit will not have an effect on this program, although it's European money. It's a pan-local enterprise partnership project. So Aerospace UP is available to SMEs in these 8 Midlands lab areas that you can see on the dark area of the map. And yeah, this slide gives you an overview of the various activities of the program. Today, we're having a focus on innovation and technology, which is really at the core of what Aerospace UP is about. We have a pot of £5.4 million available, which we would like to give out to companies in the form of grants to do innovative R&D projects. And to give you an idea of how these projects can look like, especially in the current environment where I guess doing R&D might not be something you're actually thinking about, or it's not top of your priorities. We've got the MAA's technology managers with us today to give you a number of examples of how you could develop your own projects and make use of the funding that we have available to you as a response, actually, to the current situation we're all in. Yeah, but before we do that, I'll hand over back to Andrew, who's going to give us a quick look at the MAA survey and the results of it around innovation. As you know, this whole week was themed around the 5-point plan of the MAA, which looks at how to help to rescue and recover the aerospace industry in the Midlands, and which they've developed based on a survey which was done right at the onset of the coronavirus crisis. So yeah, over to you now, Andrew.
Thanks, Christine. So if you've been on these calls before, you know that we look at our survey results briefly to give us some ideas what our members are thinking about the different themes that we're looking at this week. And as Christine said, we've kept these themes together, so to speak, so it gives us a good way to organise what we're doing. So here I'm going to look at innovation. So next slide, please. And here are the respondents to the survey, a good cross-section of MAA members, build-to-print companies, specialist service providers, and a smaller number of companies that have proprietary technologies or systems integrators that will own IP in the traditional sense we see in the aerospace world. Not that the specialist service providers and build-to-print companies don't have intellectual property with a small I and a small p, because they often have a large amount of know-how and trade secrets that they don't in fact patent for good reasons. We'll have a look at the answers that the different types of companies have given to the questions in a minute as well. Next, please. So we asked companies what they prioritized in this year and next year. This year, innovation was a very low priority, probably because people are interpreting it in terms of formal R&D programs, we think. Or it could be that they're just not realizing that a lot of the changes they're making to cope with the current crisis could be seen as innovative, and therefore, from the viewpoint of the Aerospace UP program, potentially projects that could be funded. Please. Innovation becomes slightly more important in people's thinking next year. Next. When we compare the different groups, what's interesting is that none of the groups think that innovation is particularly important to the current period. Perhaps they're pushing research programs to the right if they're undertaking them, and they certainly don't see that as a priority. But next year, not surprisingly, the systems integrators and the proprietary technology suppliers boost innovation in terms of their priorities, and that's in fact what brings it up in the average priorities of the group as a whole. Next. And that's comparing the 2 years again, this year and next year, and you can see that change in innovation becoming more important again next year. Next. If we drill down into a bit of detail, we gave companies these options. We gave these options to choose from, and then we had an open-ended question to allow companies to mention other things that mattered. So diversification is critical, the first one on this list. We looked at the rail industry yesterday, for example, and we know that a number of the kinds of projects that we run, whether they're NATEP or DRAMA or aerospace sub-projects, are about diversification in the sense that they're allowing companies to enter the aerospace industry with new technology, or they're encouraging aerospace companies to take advantage of their capabilities in other markets as well. Opening up innovation in general in the supply chain is seen as important, particularly the bottom-up kind of innovation that we promote in the MAA to support small companies to innovate. And of course, carrying on investing in green technology that the aviation industry has been doing for a number of years now is still important. And as you can see here, all three of these priorities were marked roughly equally. There isn't a clear winner in this list. Next. So when we asked our systems integrators and build-to-print companies if they had other ideas, nothing really stands out. This is verbatim what companies answered. So nothing that we particularly missed with those three priorities came out in this question. Next. When it came to specialist service providers, we did open up some veins of interest with people giving us long answers, particularly proponents and opponents of unmanned aerial vehicles had a debate, unbeknownst to themselves, in these slides, but always useful to see what people think. Next. So that's the quick summary of the MAA survey, giving you some ideas about what people thought about innovation. So I'm going to go straight on, Pamela, unless there are comments in the chat, which I'm not looking at the moment, to introduce our next session with our technology managers.
No comments at the moment.
Fantastic. So do you want to put up the first slide as we're going here? See how we're going to move on. Peter, are you introducing things?
Yes, I think I am.
Fantastic. So I'll hand over to you. And as you know, you've got all of our technology managers who've been thinking very hard about the kinds of projects that companies can undertake supported by Aerospace UP, given the new world that we're currently in. So really looking forward to see what they're doing. Over to you then, Peter.
Thank you, Andrew. Good morning, everyone. I'm Peter Knight. I'm the technology manager with the MAA. And I and my colleagues Pamela and Stan are going to talk to you a little bit about grants for innovation in this new age that we're in. Of Could I have the first slide, Pamela? So when we talk about innovation, it's often taken to mean inventions associated with new technology. So people think of patents and so on, and technological breakthroughs. And if we look at the dictionary definition, it softens things a little by saying that it introduces something new or makes changes to something established. But what we'd like to do is change that a little bit more. In Aerospace UP, we can take a much wider view of innovation. And I've listed a few things here, like obviously new technology, but new ways of working and business systems, new solutions to problems, new ways of testing or measuring, new skills to grow the business, new production equipment, new software. There's a long list, and we've become experienced in spotting innovation where people often regard it as part of their day job. So in the context of Aerospace UP, we can take a much wider view, as I've said, and what we're going to do is give you a few ideas by showing you things that companies have done with the aid of state innovation funding. Next slide, Pamela. So we've split our talk into 3 sections, bearing in mind the predicament which people find themselves in. First one is people have often, mostly nowadays, I think, order books that are significantly reduced. Obviously, grants aren't able to solve that problem, but what we could do is perhaps use a grant to increase the margin that you're able to make on the work that you do have. Obviously, many people are thinking about diversifying into new markets, so we want to give you some ideas there. And also, obviously, finding safer ways of working. So we're going to try and give you some ideas in the next half hour or so of what people have done, and try to get you to think more broadly about the term innovation. Next slide, Pamela. So we're going to start with increasing the margin by lowering the cost of poor quality. Now, this cost of poor quality is really the low-hanging fruit in any manufacturing organisation. In fact, in most organisations, whether they manufacture or not. So if you've got persistent quality issues which hit the bottom line, and I'm talking about process failures, not operator failures, of course, then the chances are you need to do something different or something new. So, and this is a very easy win for people to think about innovation, fixing problems that you have to fix anyway with the aid of a grant. So Stan's going to give you an example of a company that did just this. If we can have the next slide.
Okay. Good morning, everybody. Stan Payne here. I'm one of the technology managers with the MAA, of course, as has been introduced. I also saw that I'm going to talk about Ant Industries and a project they did with NATEP a few years ago, and I've noticed that Sean Rowley, the managing director of Ant, is in the audience today. So good morning to you, Sean. This particular NATEP project is a very good example of a very successful way of lowering the cost of quality. Ant Industries was set a very, very difficult target by their customer in a make-to-print for a make-to-print batch of products. All of these were different size engine rings up to around about 1 meter in diameter, and with wall thicknesses in the range of less than 2 millimeters. So very large, thin, flexible items. And of course, they were designed by CAD by their customer for everything, for thermal analysis, stress analyses, low cycle fatigue, everything in fact except for manufacture. And this is a common problem in the industry. Make-to-print manufacturers particularly get given things that are very, very difficult to make. So Ant found themselves spending an enormous amount of time removing the distortion of each ring after every machining operation. And they were actually spending as much time removing distortion as they were the actual machining. So this became a real problem. and it became unmanageable in terms of cost and unacceptable in terms of the number of concessions for their customer. So in this project, Ant worked closely with the Manufacturing Technology Centre in Coventry, who were able to take much of the problem offline and were very busy growing the business at the time, very little spare workforce available to address these problems. So using the MTC was an excellent way of overcoming that problem. So the MTC studied the deformation and recovery behaviour of the machine rings at every stage of the manufacturing process. And in doing so, they redesigned the tooling and fixturing with the result that the rings could be made with minimal turning in the fixture with no concessions. So it was a very, very successful project that Ant undertook with the aid of NATEP funding, and helped them to lower the cost of their quality, which is one great way of increasing your margins. And we can do the very similar types of projects through the Aerospace UP programme. Peter, back to you.
Thanks, Dan. So just to reinforce this, I'd like to just give you a quick another example. This is another NATEP project involving cost of poor quality. Naismith inherited this combustion chamber part for turboprop engine, and they inherited 3 troublesome processes along with the part. Production of holes through the thermal barrier coating on the top that you see there, electron beam welding of thin sheet steel, and bonding of a graphite liner inside. And the scrap rate was just enormous, and it seemed like if one of these 3 processes didn't get you, then another one would. So Naismith teamed up with Hucknall Sheet Metal, and they devised some new processes supported by their customer GE Czechoslovakia, and funding from NATEP. And they managed to come up with much better solutions to these processes. I guess the real point here also is this another slight angle on this is that this was a legacy part, and the real goal here was to be a supplier on the new turboprop engine which GE were designing. And Naismith were very keen to show the customer that they were more than a make-to-print company. They, in fact, could add value for the customer. Bear in mind, these processes were not originated by Naismith. They inherited them with the design of the part. So I think when you're thinking about Aerospace UP, think about whether you've got manufacturing process issues or persistent quality issues where the solutions seem evasive, because that could be very rich territory for Aerospace UP. Next, Pamela. So increasing the margin by lowering the cost, it seems fairly obvious, but if sometimes, particularly if you're in the manufacturing, where the manufacturing process is fixed, for many SMEs, without some financial assistance, this is often consigned to the too difficult or too expensive category. So Stan has an example of a company that tackled this.
Yes, although Megid aren't an SME, they do still have all of the issues in terms of costs and trying to improve the margins at every step of the way. Again, this was a NATEP project. It's a few years ago now. I wasn't involved in the project directly, but I did spend several years at the Megid division that makes bleed valves, so I feel qualified to speak on this. In this particular NATEP project, Megid cut their costs, they increased their margins, and they improved product performance at the same time. So again, this was a very successful project. They teamed up with Ashton and Moore, which were one of our region's foremost finishing companies in Birmingham, and they produced a new design of bleed valve using additive manufacture. This bleed valve is optimized for weight, reliability, acoustic emissions, and manufacturing methods. The acoustic behavior was particularly important because the compressor bleed valve on a jet engine is hugely noisy. In fact, the bleed air system is the second noisiest system on an aero engine after the core itself. So there are, in this case and in many other cases, there are often wider benefits to the supplier and user than are at first obvious. One of the characteristics of additive manufacturing, of course, is that you can end up with a design that is just hard to draw. And if you look very closely at this slide, you'll see that the shroud holes each of those shroud holes has an irregular and unique shape. You simply wouldn't have designed it like that. But that was designed with the airflow very much in mind, to smooth the airflow out, to reduce the noise of the internals of the bleed valve. So the object of the exercise from a business perspective was to maintain the existing bleed valve or reduce those non-recurring costs of the bleed valve whilst significantly reducing its recurring costs. So this was very much a production cost reduction. And the beauty of additive, as I've mentioned, is that the parts and the functions can be consolidated. The valve has very few parts compared with conventional bleed valves. Therefore, it's easier and quicker to assemble and cheaper. And it's fair to say that through that project, Megit, as big as it is, learned enormous numbers of lessons to broaden their additive manufacturing capability throughout their worldwide organisation. So very, very useful again. And additive manufacture is something else that you could participate in through the Aerospace UP programme. Peter.
Thanks, Dan. Next slide. So increasing the margin by reducing the labour content. Obviously, this is also reducing the manufacturing costs, but we're going to look at labour intensive. Next slide. So this is also an additive manufacturing project, bringing us right up to date. Harlow Engineering, based in Harlow, Essex, is an SME that manufactures electrical bus bars and fabricates electrical cabinets. These bus bars come in literally hundreds of different shapes and sizes, and they have to be spatially very accurate, which is quite challenging. The bus bars are made from copper and aluminium, and therefore high integrity applications, many in aerospace. And the numbers manufactured are typically a few tens or maybe 100 or so. So it's not enough to set up an automated production line. The bus bars are effectively handmade. So there's bending, brazing, drilling, cropping. The whole process is really labour intensive and also uses highly skilled labour. So Harlow have been benefiting from the DRAMA project, where MTC are evaluating whether additive manufacture could be used to make bus bars. One of the key parameters is electrical resistivity, which is obviously the key property of bus bars. MTC have been making samples, and Harlow are going to see how that resistivity compares with bent material, which is something that they probably could never have afforded to do without support. And you can see there, 5 becomes 1. 5 parts can be made into 1 using additive. So ultimately, the benefits to Harlow could be reduced cost of manufacture, but more importantly, de-skilled manufacture and a shorter lead time. And of course, once a customer knows what is possible, it's likely that new bus bar designs can incorporate more functionality, and it probably will only be possible to make new designs using additive. So this is really a start of a real change in the way that components are designed. Next slide, Pamela. So adding processes where there aren't any, or automating what is currently done inefficiently, can obviously bring benefits, and I want to give you a quick example of a company that did just this. So Welling Components, electronics company based up in Northumberland, and they were looking to improve quality by reducing manual handling of their circuit boards and the associated risks to the component integrity through contamination. They make a thing called a multi-chip module, which is at the heart of Rolls-Royce control system FADEX. And in this NATEP project, Welling hired a plasma cleaner from Axelonics for the duration of the project, and the cost of that hire was an eligible expenditure on the project. Plasma cleaning is used in a lot of industries and in lower criticality electronics production, but nobody really knew whether in aerospace it would be too aggressive. The ion bombardment vaporizes the contaminant on the parts, and that's literally sucked away. So the acid test was going to be whether the resultant wire bonding, and these wires are, you can't really see with the naked eye very well, at least I can't at my age. Very tiny wires and have to have a perfect bond. So that was going to be the proof. And in fact, the project did show that plasma cleaning was indeed safe and gave much improved cleaning and good performance. Pamela was able to offer support as well with design of experiments training during the testing phase. And I guess the key point here is that plasma cleaning machines are cheap. So a try before you buy option, courtesy of NATEP, was a great attraction to Welling. So thinking about Aerospace UP, there might be hardware that you'd be interested in, and there might be opportunities for try before you buy in that hardware too. So think about those sorts of possibilities and what they might bring to the business. Next slide. So new markets. Obviously, if you can, everyone's thinking about new markets at the moment, but if you can improve what you currently manufacture and make it suitable for other markets, then obviously that's a relatively quick win. So Stan's got a good example of that.
Thank you, Peter. This is a company called Advanced Innovative Engineering, and I'm very pleased to say that's a very good descriptor for this business. I've known them since pretty much they were formed about 6-8 years ago now, and they've been growing very, very quickly. Their USP, if you like, is small rotary Vankle style engines. And they've been very busy with a drama project, which is additive manufacturing, which is about halfway through now in improving the engines, which allows them to attack different types of or different sectors of the aerospace industry. So diversifying through the aerospace sectors is also a very good tactic or even good strategy for the times we're in. And I'm sure it's on everybody's mind at the moment of what you can do. So you don't have to go to an entirely different sector. You can go to the subsectors and the segments within aerospace to diversify. But first of all, you've got to have products suitable for those other markets. And keeping relatively close to what you already know can be a relatively quick win. So AIE are doing exactly that. They're currently undertaking this drama project, which, as I mentioned, is additive manufacturing, where they're seeking to integrate the heat exchange elements and other components for this engine that you can see on the screen into as few a number of components as possible. The current one is on the left, and where we're moving to is on the right. So you can see significant benefits already in the packaging. So it's a lot smaller. Not only that, but the other enormous benefits for both AIE and the customers will be a significant weight reduction. As you can see, there's a heat exchanger on the one on the left, and there is an integrated heat exchanger on the one on the right, and they're moving from liquid cooling to air cooling. So they've got significant weight savings. Simultaneously as reducing the weight, they're reducing the number of components, which also reduces their assembly time, which also reduces their costs. So it's all positive improvements that they're making with very few downsides. So by improving their current product range, if the project is successful and we're halfway through, it's looking very likely it's going to be successful. They'll be able to approach and enter new markets, which were previously very difficult for them because of their engine power to weight performance. So back to you, Peter.
Okay, next slide, please. So it's always a good idea to look at what skills you have and see whether, if you could fine tune these skills, you could enter other markets. And one thing I would urge everybody to do, if you haven't done it already, is to skills map your company and all your employees. It's amazing what some employees carry with them baggage from previous companies. And it's a really good idea to know exactly what you're capable of and maybe didn't know. And when I was at ITP, we skill mapped the whole company, every single job, every single person. And it was quite incredible the range of skills that we had that we didn't know we had. So next slide, please. So this is a company that's used their existing skills and transferring to a new market. They actually want to move into aerospace. Obviously, the things have changed a little in the last few months, but the principle is the same. And arguably, it's a good time to move into to get aerospace ready with the competition currently perhaps taking their eye off the ball. It's a great time to know what to place yourself ready for the pickup in business. So Metron's an SME based in Ilkeston, Derbyshire, and they specialise in the design and manufacture of bespoke titanium parts for critical and prestigious applications, bicycle parts for all the world's most successful cycling teams, America's Cup sailing boats, bespoke medical parts and auto sport parts. And they have an Arcam EBM machine, and they've become experts in using that machine to make additive titanium parts. And although they've made some parts for space, they've not made any parts for aerospace currently, as they didn't have the expected quality systems in place. So they got an AS9100, and now with the help of Drama, MTC are assisting them through a transition process, so their additive manufacturing processes can be aerospace ready. So here's a great example of a company using government money to transition into a new market based on proven success in a parallel market which needs equal but slightly different quality systems. And it's, as I say, a really good example of what you can do without having to learn new skills. Next slide, Pamela. So if you need to develop new skills, then of course that's a different situation, and Pamela's got a case study which she'll talk about that.
Thanks, Peter. So I've worked with Progimax in the drama programme. Progimax is a specialist engineering company with expertise in high precision engineering and have a large order book in civil aerospace flight control components particularly. The new product introduction lead at the company has been pioneering the use of polymer additive manufacturing for jigs and fixtures to solve manufacturing and assembly problems, and it's really done some quite good work in that area. Progimax intend to move into metal additive manufacturing for final use components when the time is right, which is a tricky decision to be making. They've invested in additional premises, the love building with the rainbow above it in the picture. So they've got a blank canvas to work from. So Progimax are participating in the additive manufacturing journey assessment support package delivered by the MTC under the drama programme, with a view to gaining a bespoke gap analysis and to use these results to educate the board on the journey and to make decisions about how and when to build the additive manufacturing capability. So the Manufacturing Technology Centre staff conducted a site visit to the company, accompanied by me as the MAA Technology Manager, and undertook an assessment which looked at the key requirements for adopting additive across these subject matters. So looking at their knowledge of materials suitable for additive, design for manufacture in additive, big topic in itself, how well suited they were to managing their own build process, how they might handle post-build process, which is a big issue in additive manufacturing, what they might do in-house or do externally, what the total process chain was likely to be, facilities and health and safety, the business case and skills. The bespoke report, which ran to a good 20 or 30 pages, I think, to Progimax, covered all the areas and assessed them against their level of attainment in those subject matters at the moment, and signposted a lot of information and resources to support them in gaining the skills they needed to and prioritising which areas to target first. And Aerospace UP could support similar consultancy from a range of providers to help companies work out how they're going to gain those new skills they need to win new business. Over to you, Peter.
Thanks, Pamela. So, new markets by developing new products and skills. So this is the big one where you really want to go for it. Not perhaps everybody's cup of tea, but for some it has been a very lucrative thing to do. Next slide, Pamela. This NATEP project involved a company called Heraeus Nobelite, based in Cambridge, part of a large group, and their principal product is, or was, a range of specialist lamps, including a xenon lamp, which was fast losing market share. I think it was the main product for that particular site, and they were in fear of their jobs. The characteristic of xenon lamps is that when they're on, they generate heat almost immediately, and usually that heat is just seen as a measure of inefficiency. But they asked themselves, what if you actually did want a rapid heat source? So with the help of Stan doing technology road mapping, Heraeus did some research and found that when laying down pre-preg composite fibres, heat needs to be applied to the touchdown point to make the composite tacky. So with the help of a NATEP grant, Heraeus teamed up with the composite supplier Hexcel and developed a heating system and a controller which uses pulsed xenon lamp technology. They even developed the prismatic head that delivers the light, which has its own cooling system. And Pamela helped again with design of experiments in the course of that. And the wonderful irony is that once they were losing ground to lasers, they're now displacing lasers in this part of the composites market. Their system is supplied to be retrofitted to robotic layout machines and has many advantages over laser machines, health and safety being one, and predictability of the xenon lamps as opposed to lasers being the other, because they have a very established life cycle, if you like, and it's quite possible to predict when it'll fail, unlike lasers, which is very important if you're laying up big composite panels. So just a great example of really examining what you do and drawing out the key things that might be marketable elsewhere. As I say, not for everybody, but for Heraeus, it was a lifesaver. Next slide. Of course, not all companies manufacture products. So what about companies that manufacture materials? Could a grant help with a new material or manufacturing process and progress it through to new markets? Next slide. And this is a good example of that, a NATEP project where SHD, based in Sleaford, Lincolnshire, that makes composite pre-preg material, identified a new type of resin which could replace the traditional phenolic resins used in composites. And this resin was in fact derived from the waste products of sugar beet production. Seems unlikely, but true. So on this project, they optimized the material, they built and tested panels made of the new pre-preg, and found that it in fact had a better surface finish, better fire resistant properties, was more environmentally friendly and better to produce for operators in terms of VOCs, and had at least equal mechanical performance. So this was a great example of what we call in the MAA bottom-up innovation. It's an idea which would probably never have come from top down, because it needs the experts that are in these businesses to understand what's possible and then to show customers the potential. And of course, the great thing about materials is that they're inherently cross-sector. And in fact, the sector to take up this first has been the rail industry, despite being intended for aircraft interiors originally. So while aerospace gets itself sorted out, they're capitalising on another market entirely. Next slide. So to finish this section, Stan's going to talk about a company that decided to move up the supply chain and just get a bigger slice of the available pie. Next slide.
Yes, hello again, everybody. A&M EDN are a family-owned business, basically located near the centre of Birmingham, and they've been making rotary engine parts and finishing those parts for many, many years. They realised that they built up an enormous expertise in building these components, and they decided that they would like to move up the supply chain by designing a whole engine, a whole rotary engine for UAVs themselves, and therefore move up the food chain. So when this idea really held with them, they were helped with a NATEC project to explore this idea, and so they hired a design engineer experienced in small rotary engine design, and decided to make and develop their own UAV rotary engine. So along the way, they sought and gained the support of a UAV manufacturer and lots of other partners who understood combustion and how to run test facilities, for instance. And this detailed market knowledge led them to develop a very innovative, small but very innovative 11 kilowatt Vankel type rotary engine for UAVs. It was designed from scratch, built and tested in their very own purpose-built dynamometer and test facility inside their own premises. So this was a fantastic exposition of how you can move up if you have the will, and then you gain the capability to do it. The first design of this engine ran very successfully, and they continue now to refine the engine going forward. So a great example of moving up the supply chain using grant monies to help you do so. Peter.
Thanks, Dan. So in this last section, Pamela's going to say some words about dealing with the challenges of COVID-19. We don't have many examples of this, unfortunately. I wish we did, but we don't have a lot to draw on. But over to you, Pamela.
Yeah, so the Aerospace Unlocking Potential programme was designed and bid for well before we had any hint that COVID-19 was going to be affecting our lives, but it could still be there to help with issues that are specific to dealing with the virus. And although lockdown's easing at the moment, we're through the spring peak of COVID infections, we are likely to be living with the virus in our society at some level for quite a while. So thinking this through, companies might even have identified some aspects of the way that they're working at the moment that have advantages. They may find that having their workforces working remotely has reduced pressure on office space. This might lead to the identification of requirements for digital systems to make that form of working, become a more smooth running, normal way of working rather than the crisis management way it's been done at the moment. In the workplace, adaptation might be needed to operate safely, and innovation might be required to allow the work to continue to be efficient under these constraints. That might be adding automation to reduce manual intervention and thus, reduce the need for frequent cleaning, or just automation which makes social distancing easier. And Aerospace UP can provide support for adapting any sort of working methods in this way. And as Peter introduced the topic, we're thinking of innovation in its broadest sense. And it's not a patentable change. It's not what people think of innovation as naturally, but it is an innovative way of working that we could support. The one example that we do have is a company called Acres Engineering, who are familiar to us as a manufacturer of a range of bespoke products and aids for clients in all sorts of industries, including aerospace. But that included things like stands for safe transport of valuable aero engine components, for example. And they've moved quickly to produce a range of products to allow safe working while COVID-19 is a challenge. So all sorts of screens, innovative door handles, and the sort of very practical, immediate measures that have helped people to work safely in their existing premises, with a short notice adaptation. But but all those things that I've talked about, more digital ways of working, automation and the like, might be something that your company is looking at. Back to Andrew or Peter.
I think just to finish, we don't like to blow our own trumpets, but we are really very good. I've got about 6 years experience of spotting innovation, and Stan's got even longer. Pamela's got a long experience as well, spotting things that we think of as innovative that a lot of people think of as their day job. So do talk to us.
Thank you very much, team. Absolutely super. Lots of ideas, I'm sure, will spark thinking in those who are on the call, and just fantastic to remember all the good work we've been doing, as well as you're hinting, Peter. I'm going to hand over to Christine then to talk about the way the Aerospace UP support works, potentially to support projects like these.
Yeah, thank you, Andrew, and thank you, Pamela, Peter and Stan, for your presentation just now. We really hope that these example projects are getting you to think about what you might want to do in your enterprise. And what I will do now is to just give you a very brief overview of how the grants process is going to work in Aerospace UP. If I could have the next slide, please. Which should, yeah, there you go. So this one, breaks down what we were thinking of by setting this up. So basically, we really wanted to be as flexible as possible for companies to participate. As I've said earlier in the introduction, you will have to be an SME located in one of the 8 Midlands lab areas to be eligible for the funding. The way we're looking at the process is really, to make it as accessible and flexible as possible. And so you basically are not looking at any deadlines for submission of projects. So we will have rolling calls for you to submit your projects at any time throughout the project. We're also not going to restrict you in regards to the grant value, except that the maximum value we can give out in one grant is £100,000. But you're really free to suggest how big or small the value should be according to the projects you have in mind. Initially, we'd ask you to produce an expression of interest where you're going to map out your project, where you should say what the value is that you would like to request. If you haven't yet, at this point, you would have one of the technology managers assigned to you to help you planning out your project, and they're also going to assist you to draw up the full application. And as a next step, you're already looking at the full application, where you're just building on the EOI that you've already produced. You're going to flesh that out, basically build a business case around your project, why you're doing the project, what the benefits are going to be to the company. And you'll also have to include detailed timelines at this point, financial breakdown of the expected costs, etc. The assessment of the applications are going to be based on the size and the complexity of the grants you're requesting. So if it's a higher value and complex application, we'd want to invite you to present the project to the technology board of Aerospace UP. If it's a mid-value one, we think that a peer review by industrial members will be sufficient. And if it's a small grant, that will be reviewed at the university and with the MAA together. And then you'd already, have your notice of success. We will be entering a grant agreement with you, so between the university and the company. And the contract is going to deal with all things such as the start and end date of your project. It will have schedules for claims, and just take care of all the legal side. If we could go to the next slide, please. So when we're looking at the grant value, that's the amount of support you can receive towards your project. The intervention rate that we have in Aerospace UP is going to be around 40 to 50%, depending on the region your company is based in. So you'd have to evidence 100% of the spend of the project, and the university would then refund you, for example, 40% of the spend if that was the intervention rate. This list is not finite. It's just giving you a few examples of the spend that are eligible under the funders rules. Two things I'd like to highlight here is that unlike Innovate UK grants, for example, you can't staff time, existing staff time, is not an eligible spend that we can support. However, if you were to hire staff specifically to work on the R&D or on the innovation project you're planning to do, then that's something we can put funding towards. So, for example, if you were to get a graduate student who works specifically on the project for you, that salary can be funded, and it can be a student from any university. You're not restricted to the University of Nottingham. Although I have to say our students are really great, of course. Another thing I'd like to highlight is if you're not a company located in the Midlands, so you can't be a recipient of the grants. However, if you have partners that are part of the Aerospace UP geography, they could become part of Aerospace UP. They could be receiving a grant, and then you would be participating indirectly as a third party that's providing a service towards the project. So this service provided by the third party to the project, the third point here, is really quite flexible, and you can look at all sorts of services that, as the technology managers have been saying in their presentations, that can work really well with the project that you have in mind. Yeah, I think if there are any questions in the chat at this point, that we could address, or if not, it would be time to move on to the second part of our session today.
That's what we'll do, Christine, because there aren't any questions. People are taking in all this information that we're making sure that they can't leave without having understood, which is absolutely super. Thank you very much, Christine, for giving us that background. Well, we've just got one question that we will ask. It's a pretty simple one from Dr. J.L. Hill. Is the £100,000 max value a hard limit?
Yes, it is, because we would have, I think it's state aid implications that make things complicated if we were to go above that. So yeah, 100,000 is the max value we're doing in Aerospace UP.
Okay, thanks very much, Christine. So I'm going to hand over now to Pat and Hitendra, and they're our last presenters in our Aerospace UP Week for the last half hour here. Pat Wheeler, who you're going to hear from in a minute, is the godfather of Aerospace UP. He and I started this program off thinking about it some time ago, 2 or 3 years ago now, at a dinner where we were both in black tie, and we said, we've been working closely together in the MAA and the University of Nottingham for some time in terms of meetings and events, but we haven't done a big project together, have we? What can we do? So we approached Hitendra, and then Hitendra and I developed the project. Christine came on board later on. So it's fantastic to be able to welcome Pat. I should mention Pat was also a director of the MAA for a number of years as well. So he really has maintained this relationship between the Institute for Aerospace Technology and the University and the Midlands Aerospace Alliance for some years. So welcome, Pat.
It helps if I unmute myself. Good afternoon, everybody. As Andrew said, and thank you very much, Andrew, for the welcome. I'm Professor Pat Wheeler. I lead the Power Electronics, Machines and Control Research Group at the University of Nottingham at the moment, as well as being the Global Director of the Institute for Aerospace Technology. But that's not quite what I want to talk about here. Can I have the next slide, please? Over the last couple of decades, we've been working on a lot of technologies associated with the electrification of aircraft, and this has been part of a long, ongoing process. Some of those technologies are now flying, and others are coming along. So hopefully what I'm going to do in the next few minutes is just to give an overview of where those technologies are going, where the market may expand in the future, look at some of the roadmaps that help us in looking at that. Some of the things we're developing in Nottingham, not in the context of lots of mathematics and the technology, but in terms of the opportunities that gives. And this isn't just in the electrical field. In fact, most of what is actually needed for electrification is not the electrical components themselves, but all the things that make that possible. So hopefully that's what this talk will bring. So can I have the next slide, please? So quite a few years ago, in UK funding terms, we're looking back at the CARAD programme and the Times project. So about 20 years ago now, it became obvious that there was a move in the aircraft market towards electrifying certain things. So reducing the reliance on pneumatic, hydraulic and mechanical energy systems and replacing those with electrical. I don't think any aircraft has yet done this completely, but we can see lots of examples. And the reasons why we were looking at that, if you can have the next slide, please. No, back one slide, please. Oh, thank you. The overall goals of this was all about reducing fuel burn or reducing environmental impact and reducing the operating costs, all things that come down to effectively the same thing. So those are the goals we had. And the idea was if we could simplify the energy systems on the aircraft, we could electrify a lot of the functionality that was needed. So things like the actuation systems, fuel pumping systems, the ECS system, and the ice protection. If we can electrify all of those things and use one source of power on the aircraft, hopefully that would enable us to have an aircraft which is more flexible in operation and lighter and more efficient. And we heard some of the impacts of this earlier on in terms of what the impacts this might have on other goals such as noise. Next slide, please. Following on from that, and following on from the idea of use of electrical energy, is the idea of actually using the electrical energy for the propulsion of the aircraft as well. I'll look at this in a little bit more detail. There's a roadmap here from NASA, so this is NASA's vision. I'll come on to the UK roadmap in a couple of minutes. The UK roadmap is a little bit more aggressive than the NASA vision, which is interesting in itself. But we're looking here at the use of electrical energy for propulsion on aircraft and how that might span out over the next 30 or 40 years. So what we're not looking at is flying something the size of the Airbus A380 we saw as we came into the presentations today as a pure electric propulsion aircraft in the next couple of years. That's quite a long way out. But what we are looking at is taking those steps of increasing the amount of electrical energy used in the propulsion system. Can I have the next slide, please? There's other new entrants in the market. There's lots of startup companies, as I'm sure you're aware, looking at other ways of doing electric flight. The examples I'm giving here are the sort of urban personnel transport, the sort of flying cars, if you like, and we've all seen, I'm sure, examples of these. So there are issues to the entry to the market, but it's not just about the traditional aircraft, it's also about new entrants, and particularly in a city environment, if you're going to go for an urban flying transport vehicle, electrical energy and the cleanness and the quietness that would give do have certain advantages if the other regulatory issues can be solved. Next slide, please. So if we look at the trends in electric aircraft propulsion, what we're not talking about here is removing the gas turbine or the turboprop and replacing it with an aircraft full of batteries that we would charge up at the airport. That's a little bit further away. We need to let battery technology, electrical energy storage technology, catch up with the requirements there. So what we're going to see first are far more examples of hybrid systems where there may still be gas turbines or another source of energy on the aircraft, which we could store or we can use for propulsion. So the two examples here use gas turbines. The one on the left is using the gas turbines as a way of propulsion directly, but also connecting those gas turbines to generators to allow us to have some form of distributed propulsion, maybe a bit of boundary layer ingestion going on there, and all those ideas that are coming out at the moment. If we have generation of electrical energy from the turbines as well as propulsion, we can then distribute that, and we can connect that up with things like energy storage, maybe secondary sources of energy, to give a more flexible system. And when we do that, particularly with a bit of energy storage in there, maybe in the form of batteries, we can remove some of the peak demands on the gas turbines. And that might mean those gas turbines can be smaller and lighter, and maybe run at the efficient point for more of the time. The example on the right is another example, in this case a series hybrid system, where all the propulsion is electric and the gas turbine is just being run at its optimum speed for maximum efficiency into a generator to generate the electrical energy. The advantage when you go to that type of system is the gas turbine does not need to be out on the wing of the aircraft. We can start to think about putting it in line with the passengers in the fuselage, and then having smaller, hopefully smaller electrical motors actually doing the propulsion on the wings. So these are just sort of the concepts that we can work with. There's lots of flexibility. There is no one solution. It's going to depend on the aircraft and on the system design. Next slide, please. So here's another example, but here we're also looking at the technologies we might need. So there's an example there of a power converter and an electrical motor. The thing you have to remember about both of those, and why I included those pictures, is we require the housing, we require the cooling. The one thing about power electronics and electrical machines, they are quite efficient. We're looking at efficiencies in the high 90s, but they do generate loss, and they generate it in quite a small package. So we need to have the housings, we need to have the thermal elements, we need to have the oil coolant flow or the air coolant flow. The power converter there is actually air cooled, and the motor is oil cooled. So we need to have all those components that have been talked about in the previous presentations to enable the electric flight to actually happen. So next slide, please. So when we're looking at what technology bricks are enabling this electrification, and just to give you an idea of scale, I'll have a look at it a bit more in a minute. The motor on the bottom right hand side there is a 4 megawatt motor we've been building in our labs, and it's about the same size as a 30 kilowatt industrial machine. It is not a big piece of equipment, yet it's going to create a lot of thrust power in that particular example. And the technologies that are allowing us to do that tend to be the manufacturing and materials and the thermal technologies. So you'll see on that picture on the left there that we're integrating those technologies together, from low loss materials, from intensive cooling and thermal materials, from advanced machine design. There's a lot of things happening around windings, so how to form the windings of the machine from copper, how to manufacture those, and so on. Bringing those low loss materials together into the rotor design, and of course the power electronics that go with that. If you can advance one more, please. So when we're looking at that, this chart is showing some of the technologies, particularly for the electrical machine. The wide bandgap semiconductors, that's the power electronics technology. So a big impact on the size and the weight of electrical machines, and becoming ready in terms of technology readiness levels. Magnetic materials are slightly ahead of that, but we're also looking at things like the thermal materials, what we can do with new thermal techniques within the machines, and the impact that's going to have It's almost as big as the impact of the new semiconductor technology. And additive manufacturing, technology readiness level in terms of what we need to do in electrical machines is not quite as high as the thermal materials at the moment, but additive manufacturing and how we can reimagine the design and construction of electrical machines using additive manufacturing is a massive area for us in terms of what we can do with the electrical machine design. Next slide, please. Okay, and that's just showing that 4 megawatt machine and the power electronic converter that's associated with that. So you've got to remember that power converter and that electrical machine are processing 4 megawatts of electrical energy at efficiencies in the high 90s, but therefore we do have a lot of thermal problems getting the heat from its from where it's generated and getting that out of the machine and out of the power converter. Next slide, please. So just 2 examples, and I think they tie in quite nicely with some of the things we were looking at before. This is just focusing on the windings of the electrical machine, how we need to form those windings, and some examples on the right-hand side there of how the copper of the winding is bent and formed to allow it to be inserted into the machine, maybe a process that can be automated. And on the left-hand side there, looking at some of the advantages we can get using laser welding technologies for joining and processing in enabling us to shrink down the size of the end windings of the machine to make the machine shorter, to save space and weight. So one of the things we find in aerospace is that these technologies become very, very important in getting the sizes and the weights of the machines down to enable us to look at quite seriously at these future applications in electric propulsion, as well as improving the ideas we have around the more electric aircraft. So next slide, please. The other thing we're finding with the windings as we're going up in frequency, this is a result of the power electronics, the design of the windings, how the windings are formed, how they're wound, and where each small wire within a bundle of wires is located. All these things become very important, and the impregnation, the crimping, the way we can put that bundle of wires into the slots of the machine and the manufacturing of that are all things that are becoming very, very important to us in enabling the vision for the more and the all electric aircraft to become reality. Next slide, please. So coming back to the roadmaps and where does all this fit in? Well, this is the UK ATI roadmap. As you can see, it's slightly more aggressive than the NASA roadmap. I think that's a good thing. And you can see there how we're going to be moving up in power levels and voltage, and indeed voltage levels impacting on the insulation and so on, and how that relates to that timeline. So you can see over the next 20 or 30 years, we're in a very, very fast moving generation jumping for the more electric aircraft and leading into the all electric aircraft systems. And these are going to get quite big. And if you can imagine shrinking down the gas turbines on an aircraft, maybe moving them to a different location, replacing that with electrical energy, there's a lot of things going to go on to enable that to happen. And a lot of different technologies that need to be ready to do that. And one of the trends we're seeing is that build-up of the readiness of the supply industry to be able to manufacture these parts as the more electric aircraft becomes more prevalent, and in the future the all electric aircraft becomes more dominant. So if we look at the next slide, and this is my conclusion slide, and it's really showing how there's opportunities here. And one thing you'll notice about this is how many of these technologies were mentioned in the first half of the session this morning, looking at projects, thermal technologies, additive manufacturing technologies, tooling, the design technologies, and lots of these technology opportunities are not about the electrical system themselves, but are about how we make things, how we cast things, the jigs and fixturing, the joining technologies, the tooling, and so on. So although this is enabling the electrification of transportation, particularly in this case, aerospace transportation, give a very similar presentation about automotive, very much parallel technology developments going on. But all these opportunities are there, they're growing, and I'm hoping that Aerospace UP will be something that will allow us to, or one of the methods that will allow us to work with industry to begin to improve the manufacturability of all these components that are going to be needed, both very soon and for quite a period of time going into the future. And I think at this point we need a nice smooth handover to the next slide and to my colleague Hitendra.
Hi, Hitendra Hirani, EU Program Manager at the Institute for Aerospace Technology. Thank you, Pat, for the technical introduction and for showing the kind of technologies that can be developed within Aerospace UP. I think the next part of the presentation is really looking at, okay, say we get the Aerospace UP projects going, say we start working with you guys on some of these technologies, we'll be developing a number of opportunities that come down the line. And Aerospace UP is a way of getting yourselves ready and looking then also at providing some of that technology and providing some of that experience that will also unlock the door to other modes of funding and other opportunities that are out there. So I was going to spend the next few slides giving you an introduction to some of the funding opportunities. So if we go to the next slide, you'll see that. And so that's the kind of funding opportunities that are out there. We will be sharing this presentation with you afterwards. All of those bits on the slide that are highlighted in blue are actually links, so you can click on them, you can go through, find out more information about the calls. At this moment, we've only got time for doing a quick introduction, but I think what you get from this is that there is a really rich ecosystem that's out there and a really big community that's forming around addressing the challenges that Pat was talking about. Whether it's the government's Industrial Strategy Challenge Fund, looking at driving the electric revolution, which is actually more specifically focused around PMD, but it's actually focused around the manufacturing that's involved for power electronics, machines and drives. So that's really an area where companies can get involved. A national centre for that was announced by the government, and Nottingham's leading that part of it, leading the Midlands part of the national centre. So please talk to us about how you can get involved in that. There is a current call for short-term collaborative projects. There's probably not enough time to develop a proposal around that right now, but there are going to be another few calls coming out over the next couple of years around this program. So it's really an exciting time. Of course, there is the ATI program, and within aerospace, this is much more focused on aerospace, and you can get 12 to 48 month projects that are focusing on development and maturation of products or processes. So it's really taking things that we might develop out of NATEP, which you might all be familiar with, or out of Aerospace UP, and accelerating that towards applying them into a larger context. And of course, at Nottingham, we've been involved in a number of those projects with some SMEs, with some of the other larger companies that are in the Midlands as well. So that again is another avenue that we can explore. There are also knowledge transfer partnerships. So that's where you can recruit an engineer who'd be employed by the university but would work at the company for the duration of the project. And again, what we find works very well with that aspect is because of that link and the formalization of the link between the university, for example, and any company that's involved, you get a very strong outcome out of it. And usually the person ends up working for the company after they've finished that particular project. So it's really adding a new skills base within those companies. We've also got a number of PhD studentships that are available. So there is a Sustainable Propulsion Center for Doctoral Training. If there are ideas that people want to look at, we can discuss those with you. And then lastly, the thing that's on the horizon coming in from next year is a massive €8 billion program, which is going to come on stream next year. And that's really already been defined by the large OEMs in Europe. So it's already been defined by the likes of Airbus, Rolls-Royce, Safran, whose supply chains you are all integrated into. And we can look then at how we can get involved in that. And that program is actually directed around kind of three key thrusts. So whereas previous Clean Sky programs have been quite generic and focused on large passenger aircraft or rotorcraft or regional aircraft, in this next program, they're really trying to drive the greening agenda. And there's three main demonstrator platforms that are coming together within that program. One is around hybrid aircraft. One is around more efficient short and medium range aircraft. And the last one is actually developing a hydrogen powered demonstration. So whilst these programs may look like a long way away, and they may be a little bit intimidating because there's so many partners and so many companies involved, one of the things that we have been able to do is to bring SMEs into these kinds of programs. And the next slide actually is a really good example of something like that. So this is a project which we are currently delivering with a company called NEMA, based just outside Manchester, and another SME called Power System Technology. So NEMA is actually a real example for us because it's a company that actually started out making springs. And 20 years ago or 25 years ago, they were making springs exclusively, and now they've expanded what they do. They've taken all the things that they learned about bending wires to make springs, bending bits of metal to make springs, into actually, right, can we make them more, can we make them in a better way, in low cost? Can we get more value out of these bending processes and the understanding we've developed on metals? And they've been kind of developing those skills, developing their manufacturing processes, and where they've ended up is they've now started making motors, because the skills that you need to bend a piece of wire to make a spring are exactly the same kind of skills that you need to manufacture a motor. So this project, what we're doing, if we go to the next slide now, is two aspects to it. NEMA are doing the electric motor development and manufacturing for this particular part. And another company, which is again an SME, in this case not based in the UK, but they're doing the power electronics development and manufacturing. And we're helping both of these companies with technology development. And as a university, I mean, a lot of these companies, the challenge that they have is that it's really difficult to invest in large pits of expensive equipment, but that's something that we can invest in and we can get funding to do. So we've got quite a lot of history and quite a lot of facilities and equipment that are within our facilities, and we can use them to test and integrate motors and power electronics. And using this kind of atmosphere, what it means is that we've unlocked the potential for these companies to make these components, to have them tested in facilities that would not be available to them otherwise, and deliver this component to Safran. So in this case, the component actually is a 40 kilowatt electrical motor that serves as a motor generator unit. So the idea is it sits inside a turboprop engine, and it's a mild hybrid in effect. So what happens is it generates power for the aircraft whilst the aircraft is actually flying. But then when it lands, they can use it to spin the propeller. So you're using the propeller to take the aircraft from the runway to the gate. And that has a massive fuel saving. It also has lots of noise benefits, and it has lots of benefits in terms of cutting down pollution around the airport. So it's really being seen as a real project that is really beneficial to the community. So that's the kind of example project I'm talking about, and an example of a company and a way of working between the university and a company that could deliver some output. And by the way, when the system and the engine that is being planned by Safran in this particular case goes into production, the companies that have been involved in developing it, the likes of NEMA and PST, they're the guys that are going to get the potential orders. Because they understand the application, they understand the technology, they've been developing it. So that's the kind of funding aspect of it that I had to talk about today. And then if we move to the next slide, I'd like to invite you all for any further questions. I think we've had a few.
Hitendra, thanks very much, and to you, Pat, as well, for giving that great overview of electrification in aerospace, and Hitendra for making clear to people how we can help them make their way through possible funding channels, not just Aerospace UP, but beyond it. And that's really an important element here, because we've all got a strategic objective, the University and the Midlands Aerospace Alliance, in joining up our aerospace cluster with our major aerospace university in the Midlands, if not the UK, and making the most of the possible connections using Aerospace UP itself. So Pamela, what I'm proposing that we do is go to Christine and then myself, and those who wish to stay afterwards for a good chat and ask more in-depth questions of any of the team, they can do that in the usual way. Are you okay with that, Pamela?
Yeah.
Fantastic. So over to you, Christine.
Yeah, thank you, Andrew. Yeah, thank you to Pat and Hitendra for your presentation. I think this is one of the things I really love about working in the aerospace industry. It's just the richness of technology that's involved in making it possible for people to fly. So yeah, we've pretty much reached the end of the event today. And I think it's been a really great week with lots of different interesting speakers shedding light on many of the topics that companies are dealing with at the moment. And it has certainly given us lots of ideas actually for future Aerospace UP events and workshops. And I think, yeah, we'll be certainly looking at something like expectations that employees are going to have towards their employers when things eventually go back to normal, which was one of the points that were made on Monday when we were looking at people. I think we're going to have workshops on lean thinking, for example, which was one of the topics on Wednesday when we were looking at the supply chain and how these times offer opportunities to restructure and to make our companies more resilient. Yesterday, we were talking about companies' digital attractiveness and about opportunities in the rail sector, as well as opportunities for supply chain companies to enter Boeing's supplier database. And I think all these topics are actually worth having their own workshops on in the near future. So do keep in touch with us for any updates on future Aerospace UP events. I also hope that we were able to show you this week that our academics and researchers are always interested in engaging with industry, and that includes SMEs, and that there are actually many different projects where companies can get involved with. So besides the more technical projects, there are people like Professor Bart McCarthy, who is doing research around blockchain in the supply chain, or Sophia Todt, who was with us yesterday, who does research around B2B and buyer supplier attractiveness. And I think getting involved with our researchers is really a small first step that you can take. which can bear great business opportunities for you down the line, as Hitendra has shown in his presentation. So yeah, I'll leave my contact details in the chat for people to please get in touch, and also with the technology managers at the MAA. And I think I'll have you have the last word, Andrew.
Great, Christine. Well, it won't be a very long last word. So thanks very much for summarising a lot of what we've done during the week. We've all learned a great deal through setting up this week. Ambitious as it was, we've managed to uncover a lot of new paths forward for Aerospace UP and for our companies, even in the current environment. So I really simply want to thank our MAA team, Pamela in particular, for being our producer for the whole week, as well as our technology managers who you heard from earlier. And we really appreciate everything that they put into this week, as well as the university team with Christine and Hitendra and Sarah, who's in the background, but will be an important part of the programme as it evolves, and of course to Pat for his leadership early on in the life of this programme. Finally, I guess to the university researchers who've supported us, like Pat and like Bart and Zafir, to help us to make connections to the business school and other key knowledge resources within the university. So thanks to everybody. We look forward to seeing you all next Thursday for Aerospace UP Hour, where we will find ourselves restricted to 1 hour. And we'll see how that goes. Honestly, I think we're going to do this Aerospace UP Week again in September or October, probably on the same themes and taking things further. We'll still be socially isolated to some degree. I think this way of working has been successful for us. So fingers crossed that we can set it up again in the autumn. So thanks very much to everybody. And as we said before, if you want to stay behind for a few minutes and ask any other questions, you're very welcome to do that.
Indeed.
Okay, so that's great. Let's see. Mark has a question: "Is where is the first point of contact for funding?" Yeah, it's the MAA. Mark, it's one of the technology managers like Stan or Pamela or Peter. It's the first point of call for you who are already involved with us. But the routes in are the same through the university and Christine or through our technology managers. So either route should lead to the same result. The university has a great network of its own, particularly in the D2N2 area that's going to be exploiting to use for Aerospace UP, where Christine's got contacts, and then we have them as well ourselves.
Yeah, and the emails have been coming in during the web meeting, so we've got a couple to follow up straight away, everybody.
They have, yes, ambitious projects, and I think that's good. An ambitious project, potential projects being communicating in the background through our emails, and even though Aerospace UP may not have the full budget that project needs, Hitendra has been pointing the way forward to other possibilities that we can talk to that potential project with.
And just to continue in the theme that Peter was saying, and the other people who are sounding slightly more modest and less ambitious, I wouldn't rule out, we're talking about supporting others. I really wouldn't rule out that if either Peter, Stan, or I get in amongst your business and have a look at it, that we can't find a freestanding bit of work to do with you on your own. We've done that a lot. We're pretty persistent at getting companies to join in and finding out what would be good for them, whether they know it or not.
Well, there's that, but there's also packaging up projects, isn't there? So that if we talk to people, we can see how different funding streams might be packaged up to different parts of the work. We were talking about that only when we were speaking about the rail sector, weren't we? With the diversification discussion yesterday, and the possibility of adding together two ERDF pots from different parts of the country to do different types of work with.
Yeah, no, I think there's so much funding actually available that companies might not be aware of, and that they can access all of them. Most of them are, not restricted, right? You can, do a bit here and do a bit of work there as well. And I think maybe one thing to point out with Aerospace UP, I think we're the turnover time for you to receive a grant, and I think it's fair to say that that's going to be much shorter than if you were to apply for an Innovate UK funding. So I think that's one advantage that Aerospace UP is offering, is really the flexibility we're putting into the processes, and and all the support that's available for you to go through those. Not that we will be writing your application, but we'll be here to hold your hands to go through that and to just make it work for you. Yeah.
No, I think that's right. Where Innovate UK might have the word month, we'll have the word week. So we'll be roughly that much faster. Anybody like to join our little chat at the end? We're only chatting away because you're all being quiet and we're filling the space.
And equally, I think we've segued into the informal part of the meeting without formally closing. Did we formally close
No, I
today?
formally closed. No,
oh, you did? Oh, sorry.
I thanked everybody and then I left a gap.
Yeah. You did.
To get the editing scissors too.